Now let us attempt some problems on vector algebra. We can solve these problems from the knowledge that we have acquired from my video on vector algebra part 1. Problems on dot product, vector product, etc. will be discussed in my upcoming videos. Now look at this problem. If a unit vector A make angles with I cap, which is the unit vector along x-axis, equals to pi by 3. The unit vector A make angle pi by 4 with j cap, which is the unit vector along y-axis, and make an acute angle theta with k cap, unit vector along z-axis. We have to find theta and components of unit vector A. We know that components of a unit vector is this one, where L, M, N are direction cosines. The direction cosines L is equal to cos alpha, where alpha is the angle which the vector make with I cap. In this problem, alpha is pi by 3, so L equals to half. M is equal to cos beta, where beta is the angle the vector make with j cap. Here, beta is equal to pi by 4, so M equals to 1 by root 2. Now we know that L square plus M square plus N square equal to 1. So we find the value of N from here. N is equal to plus half or minus half. Plus half means the angle theta which the vector make with k cap is equal to pi by 3, which is an acute angle. If N is taken as minus half, then angle theta would be 2 pi by 3, which is not an acute angle, so this is discarded. Now the unit vector may be written as L I cap plus M j cap plus N k cap, which is equal to half I cap plus 1 by root 2 j cap plus half k cap. So these are the components of the unit vector A. Now let's come to the second problem. Here A, B, C are three vectors with magnitude 3, 4 and 5 respectively. Each of the three vectors is perpendicular to the sum of the other two vectors. We have to find the magnitude of the sum of the vectors. Now we know that any two vectors and their sum lie on the same plane. This means a vector A, which is perpendicular to the sum of vectors B and C, is also perpendicular to vector B and vector C. So in other words, each of the vectors A, B and C are perpendicular to the other two vectors. That is, vectors A, B and C are mutually perpendicular vectors. That means vector A, B and C may be represented by the adjacent sides of a cuboid in a three-dimensional real coordinate space. Their sum will represent the diagonal OG of that cuboid, and magnitude of the sum of A, B and C is the length of OG. OG is calculated simply by the formula where the length of a diagonal of a cuboid is equal to the square root of the sum of squares of the adjacent sides of the cuboid. In this case, it is equal to square root of OA square plus OB square plus OC square. The answer is 5 root 2. Now let us come to the next problem. In this problem, it is given that the sum of two unit vector is also a unit vector. We have to prove that the magnitude of their difference is root 3. Now we know that sum of two unit vectors is a unit vector which is given in the problem. We also know that the sum of two vectors is represented by the diagonal of a parallelogram when the two vectors are representing the adjacent sides of the parallelogram. Here OA equal to A cap, whose magnitude is 1, and OB equal to B cap, whose magnitude is also equal to 1, and OC equal to C cap, whose magnitude is also equal to 1 because C is equal to A plus B. This we get from the parallelogram law of vectors. For OC to be a unit vector, triangle OCB should be an equilateral triangle. Therefore, angle CBO is 60 degrees. This implies that angle AOD is also 60 degrees. because CBO and AOD are corresponding angles. Therefore, DA equal to OA sine 60 degrees, which is equal to root 3 by 2, and OD equal to OA cos 60 degrees, which is equal to half. Now vector BA equal to vector BC plus vector CA. This is the triangle law of vector addition. Or BA equal to BC minus AC, because CA equal to minus AC. Or BA equal to A minus B. To find the magnitude of this vector, we focus on the right angled triangle ADB and apply Pythagoras theorem. Therefore, AB square equal to AD square plus BD square, which is equal to AD square plus OD plus OB square, which is equal to root 3 by 2 whole square plus half plus 1 whole square, which is equal to 3. Or magnitude of AB, that is magnitude of A minus B, is equal to root 3. Thus it is proved that the magnitude of the difference of the vectors is root 3. Now let's come to the next problem. We have to prove that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and equal to half of it. You all have done this problem without using vectors in plane geometry in class 9. But today we will do it by vector method. How? In triangle ABC, we will take C as the fixed point, which will be the initial point of all position vectors. Therefore, position vector of point A is vector CA, which is equal to vector A. And position vector of point B is vector CB, which is equal to vector B. Let D and E be the midpoints of CA and BA respectively. Clearly, CD and CA are collinear vectors, and because modulus of CD is equal to half of modulus of CA, therefore position vector of point D, which is vector CD, is equal to half vector A. Now vector CE is equal to position vector of E, which is equal to vector A plus vector B divided by 2. This we get by using the section formula, as E divides AB in the ratio 1:1. Therefore, vector DE equal to position vector of E minus position vector of D, which is equal to vector A plus vector B divided by 2 minus half vector A, which is equal to half vector B, which is equal to half vector CB. This proved that vector DE or DE is parallel to vector CB or CB, which is the third side. Also, magnitude of D is equal to half the magnitude of the third side, that is half into CB. Thus we prove it, and the problem is being solved by vector method. Now let's come to the next problem. In this problem, there are 3 points A, B, C. The position vectors of these points are given. We have to prove that they are collinear. To prove this, we will first find vector AB. What is vector AB? AB is position vector of B minus position vector of A. And we calculate it, and we find that vector AB is equal to 3A minus B minus 2C. Similarly, we find vector BC, which is equal to position vector of C minus position vector of B. Again, we calculate it and find that it is equal to 6A minus 2B minus 4C, which is equal to 2 into vector AB. This proves that AB and BC are collinear. If AB and BC are collinear, it proves that points A, B, C are also collinear. Now let's come to the next problem. Here, two vectors are given, A and B, both are unit vectors, and they are inclined at an angle theta. We have to prove that sine theta by 2 equal to half into magnitude of vector A minus vector B. Now let's draw the diagram like this. Here, OA and OB are unit vectors inclined at an angle theta. This parallelogram OACB is actually a rhombus with 4 sides representing unit vectors, that is, their length is same, so it is a rhombus. Now in a rhombus, the diagonals are perpendicular to each other. Therefore, angle ODB is equal to 90 degrees. Also, diagonal OC bisect angle between OA and OB. This only happens in a rhombus. This means angle BOD is equal to theta by 2, where theta is the angle between OA and OB. Also, we know that in a rhombus the diagonals bisect each other. That means magnitude of BD is equal to half the magnitude of BA. Now vector BA is equal to vector BC plus vector CA, which we get from the triangle law of vector addition, which is equal to vector BC minus vector AC, because vector CA is equal to minus vector AC. Therefore, vector BA equal to vector A minus vector B. Therefore, vector BD is equal to half vector A minus vector B. Hence, magnitude of vector BD is equal to half the magnitude of vector A minus B. Clearly, in the right angled triangle ODB, BD equal to OB sine theta by 2. Now we know that OB equal to 1, therefore BD equal to sine theta by 2. Now BD is equal to half magnitude of A minus B, which is equal to sine theta by 2. Thus we prove our point. Now let's go to the next problem. Here three vectors are given. Vector A is equal to 2i cap minus j cap plus k cap. Vector B equal to I cap plus 2j cap minus 3k cap. And vector C equal to 3i cap minus lambda j cap plus 5k cap. Now we have to find the value of lambda, and what is given that these three vectors are coplanar. Now the conditions of coplanarity is this, that is vector A equal to x into vector B plus y into vector C, where x and y belong to set of real numbers. Now we actually substitute the values of A, B and C in this equation, and we get 2i cap minus j cap plus k cap, which is equal to x plus 3y I cap plus 2x minus lambda y j cap plus minus 3x plus 5y k cap. Now we compare components along I cap and k cap. First we compare components along I cap. Here the component is 2i cap, and on the right hand side the component along I cap is this, that is x plus 3y I cap. We equate it, and what we get 2 equal to x plus 3y. This is equation number 1. Now by comparing components along k cap, what we get 1 equal to minus 3x plus 5y. This is equation number 2. We just solve these two equations, and what we get x equal to half and y equal to half. Now we compare components along j cap. After comparing components along j cap, what we get minus 1 equal to 2x minus lambda y. Now we put the values of x and y which we got previously, that is x equal to half and y equal to half, and then calculate lambda. What we get lambda equal to 4, and thus the problem is solved. Now let's come to the last problem. Here in this problem a triangle is given. The triangle is ABC, and points L divide BC in the ratio 1:4, and point M divides CA in the ratio 3:2, and point N divides side AB in the ratio 3:7. We have to prove that vector AL plus vector BM plus vector CN is a vector which is parallel to vector CK, where K divides vector AB in the ratio 1:3. We see in this diagram that point L is over here, which divides BC in the ratio 1:4, and this is point M, which divides CA in the ratio 3:2, and here is point N, which divides AB in the ratio 3:7, and this one is point K. Point K divides AB in the ratio 1:3. Now let C be the fixed point for determining position vectors. Let position vector of A, that is CA, equal to vector A, and position vector of B, that is vector CB, equal to vector B. Then position vector of L, that is CL, which is collinear with CB, is equal to 4 by 5B, right? 4 by 5B. Now position vector of M, that is vector CM, is 3 by 5A, because CM and CA are collinear. Now position vector of N, that is vector Cn, is equal to 7 by 10A plus 3 by 10B, which we get from the section formula. And position vector of K, that is vector Ck, equal to 3 by 4A plus 1 by 4B, which we again get from the section formula. Now vector AL equal to position vector of L minus position vector of A, which is equal to 4 by 5B minus A. And vector BM equal to position vector of M minus position vector of B, which is equal to 3 by 5A minus B. Therefore AL plus BM plus CN equal to this, which is equal to, we calculate it over here like this, we get it is equal to 2 by 5 into vector CK. Therefore AL plus BM plus Cn is parallel to CK, and we prove our point. Hope you have benefited from this video. See you next time on my upcoming video, which will deal with dot product and vector product of two vectors. Thank you.